Hello there and welcome to the June 2018 paper. Here we're looking at question 7. So we have a function f of z which equals z cubed plus z squared plus pz plus q, where p and q are real constants. The equation f of z equals 0 has roots z1, z2 and z3. When plotted on an Argand diagram, the points representing z1, z2 and z3 form the vertices of a triangle of area 35. Given that z1 equals 3, find the values of p and q. Well, first of all, if I have z1 equals 3, then if it's on an Argand diagram and making myself an area of 35, then z2 is going to be some complex number, we'll call it a plus bi, and z3 must be its complex conjugate because it's a solution to a polynomial with integer coefficients, so they must be complex conjugates of each other. So let's draw this on the Argand diagram to visualize. If this coordinate here is 3, then we're going to have to make a triangle. Either it's going to be on this side over here to make the triangle, or it's going to be on this side over here. So potentially two values of A and two values of B, but we'll see. We'll have a look at what we do to get this. So what I also spotted was that we do know the coefficient of z squared. The coefficient of z squared is 1. So when we add the coefficients together, we can use the summation. So when we can use the sum of the roots formula for this expression here as well. Let's first of all use the area calculations. So the area of this triangle is going to be, let's just for example use this thing on the left hand side here. If we've got this as our value for A and this height as our value for B, then it's going to be 2B on the base times 3 minus A, and that's going to equal 35. So yeah, so I think we'll just leave that there. I don't think there's too much more we can kind of do with that really. Let's now use the summation of the roots. So the summation of alpha equals, it's going to be 3 plus a plus bi plus a minus bi equals, and it's going to be minus b over a, so this is going to equal minus 1. So when we add all this together, we're going to get 2a, the bi's cancel out, plus 3 equals minus 1. So subtract that 3 onto the side, you get minus 4. So a is minus 2. So now we definitely know that a is this left-hand side one at minus 2, and it's not this right-hand side one over here. So the triangle is definitely positioned here. Now we know that a is minus 2, we can substitute in minus 2 into this little formula here. So the 2's will cancel out on the area there. The 2b, because remember it's going to be 2b because we have to go up by b and down by b, so the base there is going to be 2b. So it's 2b, but then you divide by 2 for the area of a triangle, so the 2's cancel out. So it's just going to be b times 3 minus minus 2 is 5 equals 35. So therefore b is going to equal 7. Okay, so we now know the value of our two new roots. They're going to be minus 2 plus 7i, and z cubed equals minus 2 minus 7i. So those are our two complex numbers there. Now there's two different ways that we can now go ahead and work out what this cubic is. You could use the sum of the roots formulas, some of the doubles roots formulas and the triple root formulas, or you can just do it by the kind of complex number method. So if you've got z equals minus 2 plus or minus 7i, then z plus 2 equals plus or minus 7i. And then if we square both sides, it's going to be z plus 2, my pen's a bit lagging here, z plus 2 squared equals minus 49. And let's now expand it and move everything onto the left hand side. You're going to get z squared plus 4z, and then it's going to be plus 4, but then plus the 49 as well, so it's going to be plus 53. equals 0. So that would be the quadratic that will give these two roots. So now you just need to make it a cubic by adding in z minus 3. So z squared plus 4z plus 53. And then z minus 3, because that little bracket there will give you the z equals 3 root. So let's just expand and simplify now. So the answer is going to be z cubed. It's going to be 4z squared minus 3z squared, so plus z squared. Good, we already knew that, so it's good to check that. Then it's going to be minus 12 plus 53. Let's just grab a calculator. 53 minus 12. Should be able to do that, shouldn't I? Plus 41z. And then 53 times minus 3. 53 times 3 is minus 159. And that equals 0. So there we are. So the value of P is equal to 41. And the value of Q is equal to minus 159. And there we are. Those are the answers for this question here. That's 7 marks for that question, 7 there in total. Let's now move on to question 8.